This is my daughter's AC induction motor that she made for her HSC assignment for physics. We thought we'd make this video for you because we found, or she found, so few induction motors on the internet that could be replicated, and often there wasn't much explanation. We have a 15 volt AC power source and it's a 2 amp maximum output. That's what we had, so that's what we used. If I switch it on, you'll see that it starts well without hesitation, and that's what you're required to do for the HSC. You would have looked up by now how an AC induction motor works, but basically on this motor we have two parallel circuits, each containing two electromagnets. One of the circuits are two electromagnets in series, and they are the ones that are horizontal, and of course the other circuit is two vertical electromagnets in series. Doesn't matter which one, but you need to choose one of those circuits to have capacitors to change the magnetic field, so it cuts in and cuts out and draws the attraction, which enables the motor to turn, as you've looked up hopefully on the internet. In the end we tried various different capacitors, but in the end we had to add up to 300 microfarad, and so we have three 100 microfarad capacitors in parallel. That makes them add up, and they need to be bipolar to allow for the AC current going backwards and forwards through the wires, through the circuit. The rotor, I think it's called the rotor itself, is just a simple tin can. It could be baked beans, it could be peaches, whatever. We've chosen steel because it has greater magnetic attraction and it goes quicker, I assume, than doing aluminium, though we didn't try the same experiment with aluminium. Many induction motors you'll see will have aluminium, but the steel, as you can see, works very well. It's mounted on a 10mm rod, hollow rod, available from Bunnings for a couple of bucks, and it goes into bearings that we bought off eBay for about $2.50 each. And these ones work, I think they're flange bearings, and they work well because it's got, you can actually tighten the aluminium bar onto the bearing, so it's a good contact. With the cabinet that she made there, it's a little bit out of square, and so we've had to loosen off a couple of the screws to allow for that, and you might find that you need to do some adjustments to make sure that there's no friction and so that it spins well for you. One way to overcome this though is just having one bearing and a short rod and maybe a smaller tin, though you could use the same tin. This would still operate if we took one end off. There's enough, because of the type of bearing, there's enough to hold it there. And you don't have to have it horizontal like this one is. You could also have it vertical like we saw on other motors displayed. Just a couple of tips on making the coils. I think we used a 4 5/16 bolts. We tightened the nut up to the end of the thread, and then we wound the wire on there. We wound it so that there was 600 windings, and to work out how much wire we'd need per electromagnet, we calculated 600 by the diameter of the bolt. And for us that turned out to be approximately 15 metres. So all up we have 60 metres of lacquered wire, and we wound that on by using an electric drill. One person holding the drill and operating the drill, the other person holding the wire and as neatly as possible trying to wind it on to the coils. As you can see, it works very well, and we hope that when it comes time for you to do your assignment, that you go very well.